Okay, 2-4, the chain rule. So you have the product rule, the quotient rule, and I won't even from now on even talk about like the constant multiplier rule, all those, because they're just there. You just do them. So you have the chain rule, you have product and quotient. Well, after today, you'll have the chain rule. Okay, so without the chain rule and with the chain rule. So you don't really need to write this down, but you just need to see. Without the chain rule, I can do x squared plus 1. But I can't do that with the square root of x squared plus 1. What is the difference between the two things?
One's a square root.
One's a square root. So this is a function, yes? Is the square root a function? Yes. So I have a function in a function, don't I? That's why I can't do it without the chain rules. You get what I'm saying?
If it was x plus 1, could you do it? Or it would just have to be like x?
It would just have to be x.
So it can't be anything else other than
No,
x?
because in here, it's just like when we can't reduce unless you can factor. It's the same thing. So like, let's say f of x is the square root, but g of x is x squared plus 1.
So you couldn't do f of x because this is implying that it has x squared plus 1 in it?
Well, you couldn't, I could do this,
Yeah.
okay, but I can't do a quantity. I can't, when I have this is a quantity, I have to work with it first. Okay? So I can take the sine of x, but I can't do sine of, and we should have what here? Parentheses. So 6x is the function inside of sine itself. I can do 3x plus 2, but I can't do 3x plus 2 quantity to the fifth, because the fifth is the outside function, and the 3x plus 2 is the inside function.
So this is just saying what you can do and what you can't.
Well, we're going to learn the chain rule so we can do these.
Yes.
Because before today, you couldn't. You wouldn't be able to. So I could do this, but can I do this?
No.
No, because it's not tangent squared, it's actually x squared.
If it was
So-
tangent squared, could you do it?
Yeah. If it was tangent squared, you could. If it was this, you could, because it would be 2 tangent
Oh,
to negative
to get the
first.
derivative of it.
Right. So the chain rule is as follows. If f of u is differentiable and u equals g of x is the differentiable function of x, then y equals f g of x. So composite functions, that's why I want to point out that these are composite functions. You're just not doing the composition. The composition's already been done. Then we have this right here is our chain rule. Okay, so d dx of f g of x, so d dx of a composition of functions is f prime g of x g prime. So what that says is the derivative of the outside function times the derivative of the inside function. So that first part, you take the derivative of f and you don't touch g. See that? Now, I do know some people that have struggled with it, so they always take the derivative of the inside because they think of compositions as you're putting the inside into the out. Can I take the derivative of the inside times the derivative of the outside? Yes, because it's multiplication and you can switch it around. I've never had an issue remembering it. Am I good?
Yeah.
Okay, so what is the outside? What is the inside? What is f of x? We'll say f of x is the outside. Cubed. So it'd be like x cubed. Yes? And what is the inside?
3x minus 2x squared.
3x minus 2x squared. So g prime of x is going to be the derivative of the outside with g of x in it. So the derivative of x cubed is what? 3x squared. But our x is going to be what? 3x minus 2x squared, all squared. Times the derivative of the inside. Well, the inside, we're just going to use our normal rules, right? So the derivative of 3x is 3, and the minus, and the derivative of 2x squared is 4x. Questions?
You just leave it like that?
Yep. Now, if we could, I guess we could multiply out and.
No, I just want to make sure.
No, I'm just saying, if it was something that was just two binomials, then sure, you would multiply it. But it's this, it's fine.
So you just find the derivative of the outside,
Mm-hmm.
and then you just would plug it in the x like you would a normal composition,
Mm-hmm.
and then you just add the derivative
Multiply.
inside.
Multiply.
But yeah, that's what I meant in my head.
Okay.
Sorry, Mom. Okay.
Okay, so what's the outside function? So
Excellent.
1/3. And the inside is x squared minus 1, quantity squared. Oh, wait a second.
So would the outside be 2 over 3, or would we have 3?
So we're going to have 3 of them, aren't we?
3 what?
Because we have the outside being x to the 1/3, yes? But we also have this. We could do 3, but couldn't we just take this 2 right here and put it here?
That's what I said.
How do you do that?
Like writing it like that?
Because, let me show you. So you have x squared minus 1 to the second, all to the 1/3. Don't you multiply these two together?
I suppose you can.
I suppose.
Um,
Okay, so g prime of x. So we need to take the derivative of the quantity to the 2/3. So 2/3, right? The stuff in the middle to the negative 1/3 times the 2x. Okay, so now we can't leave this one. Why can't we leave this one? We have a negative exponent and we have a fraction, but it is all multiplication, so I don't have to factor things out, do I? I can just move them around. So what stays on top? The 2 and the 2x, so that gives me what? 4x. And the bottom is just 3x squared minus 1 to the 1/3. Oh, no.
Hey, they let us leave it like that.
Nope. I mean,
Yeah, I know. That's why my cellular device is up there.
yep. So what's wrong now?
You have a fraction of a exponent.
Okay, so what do I need to add to 1/3 to get to a whole? 2/3. So that would be 4x x squared minus 1 to the 2/3. All over 3 times x squared minus 1. And if you didn't want to leave a fractional exponent, we can put it back in a radical. So it would be the cube root of x squared minus 1 squared over, you want to distribute the 3 or leave it out?
Leave it out.
Okay. So 3
Roll for exclusion.
x squared minus 1. Not too bad, is it?
If I can follow it.
Okay, so could you continue this with multiple functions? Like functions, in functions, in functions, in functions.
I guess.
You could,
But why would you?
and sometimes you have to.
Let's hope not.
And then we have to combine all of them together.
I don't like this. So I'm trying to figure out how to do this. So the reason you got to leave the other one how it was and you didn't leave this one is because this one had the negative and it had stuff in the numerator and denominator, right?
Yes,
Okay. I just want to make sure.
yes. Has to be the prettiest it can be.
Oh, we didn't drink my outside.
And we do. Okay. What do we got to do with this one?
Write it down.
Well, that's usually a start. Can this -7 just go out in front? We can just kind of kick it out, can't we? So we could rewrite it as -7 2t to -3 to the what power?
-2.
The -2.
Can you just do that because it's a whole number?
Yep. It's a constant. So that -7 is just going to hang out, right? So -7 times -2 would be 14. What?
How'd you multiply it? You just-
Because I brought this for the derivative.
Oh,
Okay, so it's 14 2t minus 3 to what? -3 times 2. So I gotta simplify this one, right? So what do I get?
28 2t minus 3 third.
Am I good?
yeah.
Okay, now we've got a product, yes? With, so we're going to have to combine the product and the chain together. So I have f of x equals x squared. Now, if it's me, I'm not writing the square root of 1 minus x squared on my paper, even in notes. What are you writing?
1 minus x squared to the
Okay, so we are going to have to do the product and the chain rule. Because we have a multiplication right here. And then we have a composition of functions there. So remember the product is f prime g plus g prime f. Yep. Okay. So f is going to be your x squared and g is going to be this composition. Yes? Okay, so what is the derivative of x squared?
2x.
Okay, So I have 2x and then just times g, the whole thing. So 1 minus x squared to the 1/2. What, Natalie?
Why isn't the 1/2 part of the x squared? Is that part of the other thing then?
Well, this right here is g,
And then the other.
and this is f.
That's where you keep losing me.
So we have like basically f, g, and h, because h would be the composition function, the one inside g. So now plus, now here we probably want to just put x squared first, don't we? Okay, so I am going to put a bracket so my brain knows I am now switching gears. So we wrote f there. Now we need to do g prime. So the g prime are going to have to use the chain rule. So the outside function is quantity to the 1/2, yes? Which is what? What's the derivative of a quantity to the 1/2? 1/2, and then the quantity to the negative 1/2. Now I need to do the derivative of what's inside, so 1 minus x squared. So the derivative of 1 minus x squared is negative 2x. So questions before we start simplifying? Okay, so this is, I want everyone to realize in your brain, this is all multiplication, yes? So I can factor things out of that. And I don't particularly want to distribute it. I can. I would rather myself do some simplification first. So is there anything I can simplify out of that second quantity? Because I have 1/2 and I have 2, yes? Okay. And then I have x squared and x, so I have negative x to the... And I am going to write it just so you can see it. I typically don't rewrite it.
Oh, they want to show you the lamb.
Okay, so on this second one, then I now have negative x to the third. Where did I get negative x to the third from?
Removing x from the parentheses.
Okay. So now I have a problem. I can't just move things to the denominator anymore, can I?
No.
Nope. So let me go back to blue.
So you're moving the table.
I'm not asking.
So what can I factor out? Well, I've got to factor out the negative, yes? But what can I factor out of those two quantities?
1 minus x.
An x
Or minus x squared.
and 1 minus x squared to what power?
Just 1/2. Or the negative.
The negative 1/2. Because the negative 1/2 is what can't be in the numerator, correct?
Indeed, yes.
Yes? Okay, so when I divide 2x by x, I'm left with 2. And when I divide a quantity by a quantity and I have exponents, I subtract. But when I subtract a negative, I add. So 1/2 plus 1/2 is a whole. So that gives me 1 minus x squared. And then I minus. I took out an x, so I have x cubed. And I'm factoring out the x minus 1 minus x squared to the negative 1/2, so that just leaves me with 1, right?
Yes.
So I'm done there.
This is blue.
Yes, ma'am.
That'd be x.
Yeah, wouldn't it be x squared?
Oh, I said x squared and I wrote cubed, didn't I?
I think you said cubed.
Did I?
Yeah, you did.
I said you could factor it out, but I guess I just didn't do it. Okay, now what can I do? What can I do? Well, doesn't this become 2 minus x squared? Oop, 2 minus 2x squared?
I suppose it
So
would.
then you can combine your like poems.
Okay, so the x stays in the numerator, yes? So x. And the 1 minus x squared to the 1/2 goes in the denominator.
Thought we couldn't just put stuff in the denominator.
Well, we factored it. It's multiplication now.
Oh, now we can.
And then in the quantity, I'm left with 2 minus 3x squared. Okay, I'm all good,
Done.
except
No.
the fraction.
Exponent fraction.
So I need to have, well, if I have this times, oops, nope. Forget my words. Okay, so I know, you do it every day. We got this up here, yes? And this goes to a 1.
Yeah.
So can I combine these two? No, I cannot. No.
Because you're multiplying.
This is in a square root, yes. And so can I combine them? No. If the quantities were the same, could I combine their exponents?
So then you just have to leave it.
So I have x and then 2 minus 3x squared times the square root of 1 minus x squared all over 1 minus x squared. And I will tend to leave parentheses on everything so my brain doesn't go, ooh, look what magic I can do now. Because I told you guys you were doing like mathematic cartwheels before. Now we're doing some back handsprings and some tucks and, right?
I don't think I can do
Natalie's knees might go out.
Yeah, my knees aren't safe.
Well, the only kind of gymnastics Natalie is going to do is mathematics gymnastics.
I don't think I can do that either.
I think so. I
My
believe in
knees are
you.
pretty weak.
I believe in you.
No, you don't.
Your mental capacity is stronger than your knees.
What is that week, Natalie? What was your squat to failure today?
I didn't do squat. That's how weak I am.
Okay.
I don't do squat. Let's do squat.
Okay.
I did,
I can do 265 on squat.
Hey.
I did 225 20 times.
Sorry.
Okay, so in the past, you guys would be tempted to bring that cube root up to the numerator, yes? I'm going to tell you no. Because do you have something that can deal with that? Don't you have a quotient rule?
No.
Yes? So we are going to do a quotient chain. So the quotient rule, f prime g minus g prime f all over g squared. Okay, so that's numerator, denominator, right? So, and this is going to be the 1/3 down here, isn't it?
Yeah.
Okay, so f prime of x, well, the derivative of x is what?
1.
1. Whoa.
I'm so smart.
So x squared plus 4 to the 1/3.
I've never heard of this before.
Minus. Well, f is just x, yes? Now we're going to have to perform the chain rule on the denominator because the outside function is to the 1/3. So you don't have to do the brackets, but my brain keeps things better if I do. Because then I can go back and check that I did things. So what do I get?
1/3 x squared plus 4 to 1/3.
Nope. X squared plus 4 to the what?
Negative 2/3.
Yep. Times 2x. Kayla, you know what you did, right? When I said no.
Yeah.
Okay. All over x squared plus 4 to the...
It's about the 7/3.
How about 2/3? Where are you getting 7/3?
Because I added instead of multiplying
Oh.
exponents.
Okay. So 2/3 because it's squared, yes? Unfortunately, there's nothing we can reduce out,
So
So we're done.
but we have to get the 1/3 out and the negative 2/3, don't we?
Not really.
Yeah, we do. So we got to factor out 1/3, and we have to factor out x squared plus 4 to the negative 2/3. And I'm going to go ahead and write my denominator, then I don't have to worry about forgetting about it, because I tend to like drop it off the face of the earth if I don't.
You can just factor out whatever you want.
Okay, so when I factor out a 1/3, I have to multiply by what?
12.
3? Where'd you get 12?
I'm just being I didn't know.
Okay. Well, when you factor, you divide. When you divide by a third, you multiply by 3.
Yeah.
Okay, so the first piece just gets a 3, yes. And then I have 1/3 minus the negative 2/3, which gives me 1/3 minus a negative 2/3. So you get a 1. So I get x squared plus 4 minus 2x squared. Is that right? Because the 1/3 would come out, and the x squared plus 4 to the negative 2/3 came out. So I have an x and a 2x. So I have 2x squared. Are we going too fast? Am I going too fast?
Very slightly.
Okay. Okay, so what comes in the denominator?
What comes in the denominator?
And what goes down there? 3, right?
Oh, yeah.
And then we'll have all this to the 2/3. So the 2/3 and 2/3 is what?
4/3.
4/3. And then my numerator would be 3x squared plus 12. So that, I think, would just be x squared plus 12. So x squared plus 12. So what do I need to add to 4/3 to get to the next whole number? 2/3. So my numerator is going to be x squared plus 12. That's a horrible 2. 12. And then x squared plus 4 to the 2/3. All over 3. And then 4 plus 2 would be 6. Divided by 3 would be 2. And if you don't want the fractional exponent, what would it change to?
Cube root of the whole thing squared.
Yep. I always struggle with how I write that. Sometimes I like it one way and sometimes I don't. There we go. That one problem, I should have chained it twice. Okay. Questions?
How many more?
I don't know.
Well, we have 5 minutes left, so we're probably
Ooh. Now we had a chain inside of a quotient, yes? But before we had a chain inside of a quotient. Now we have a quotient inside the what? Chain. Okay. You only have 5 minutes, is that what you said?
Yeah.
Okay, I'm going to give you this and we'll come back. So you need this. Okay, remember U right here. U is another function. Okay? U is the inside function. So the chain rule, when it applies to sine, you get the cosine of U times the derivative of U. So essentially, the derivative of the outside times the derivative of the inside. Just what you've been doing. They just have written it out so you can see what's going on. Does that make sense? You hope so? And I'll just let you write.
Good choice.
So we're not going to finish today, obviously. So you need to work on your assignment to what you can do. Okay? Now, the last part, the last section is trig ones. So you can try them. Okay? We will answer any questions. We can finish more examples if you want tomorrow. You have the one assignment for 2 days. I kind of like doing that.